In this lesson, we're going to walk through some factoring word problems. And what I mean by that are word problems that when we set their equations up to solve for whatever the problem is asking, we will likely be using the factoring methods to help solve those equations. So when you are presented with a factoring word problem, you need to go through a few things. The first, as always, is to start by defining the variable for one object. So for all of these problems we're going to look at today, we're going to write all of the missing expressions or missing objects in terms of the same variable. So these are not like system word problems where we might have an x and a y. We should only be using one variable all the way throughout our equation. We will define the expression for another object using that same variable. So we've done this before this year. For example, if I used L for length of a rectangle, then for width I might write the expression for width using L. So I'm still using L the whole way through. Once we've done that, we're going to set up an equation that shows the word problem's operation or equality. So this means we're not starting to solve anything. We're just doing really a translation of what the word problem's telling us will help us solve for the missing pieces. This is the part that will probably be the new application portion, where you're going to find that with these equations, when you start to solve for your variable will gain an exponent that will be higher than 1. So when we have exponents higher than 1, to solve those types of equations, we have to use the factoring methods. After you've solved, you will cross out or eliminate any solutions that do not make sense with the word problem. So we'll talk about this throughout the lesson, but what can happen is sometimes you get a negative value for your variable. However, you're dealing with something like length or distance, and we can't have distances be negative. So in that case, we would cross off the negative solution that would not make sense and only use the ones that make sense with the word problem. And finally, state your answer by using the solution value that makes sense and plugging it back into your defined variables from steps 1 and 2 if needed. All right, so let's take a look at our first example. Ray is 6 years younger than Sam. The product of their ages is 112, and we are to find Ray's age. So there are several keywords in here. First, this first sentence is actually describing how we're going to set up our variables. Ray, whatever Ray is, he is equal to 6 years younger than Sam's age. So this means whatever Sam is, we're going to subtract 6 from his age. So when you're defining your variables in your first step, remember that the object or person in this case that you know the least about is usually the one that will be your variable. So if Ray is 6 years younger than Sam, we're being given a lot of information here about Ray and almost nothing about Sam. So we're going to call Sam our variable, and I'm just going to use X. Once we've defined Sam as X, I can come back to my word problem, put an X above Sam's name, and write an expression for Ray now. So Ray is equal to 6 years younger than Sam. So whatever Sam is, remember younger than means we flip the order. We'll have X minus 6, 6 years younger than Sam. Okay, so these are our two people, and we now have expressions for both of them using the same variable. Then it tells us the product of their ages is the equal sign 112. Product means to multiply. So to set up our equation, we need to multiply Sam's age, which is X, by Ray's age, which is X minus 6, and set it equal to 112. From here, this is where we'll start to solve. So that means we need to simplify first, giving us x squared, oops, I went too far, x squared minus 6x equal to 112. And now we notice, okay, we've got an exponent higher than 1 on a variable. So to solve equations like this, we're going to set them equal to 0. So I'm subtracting 112 from both sides. And from here, we will then factor. to finish solving for x. So now we're applying our solving equation processes for using the factoring method. So to factor, we need factors of negative 112. This is a trinomial without a coefficient that add up to negative 6. And so those factors are negative 14 and positive 8. Negative 14 times 8 is negative 112. They also add up to negative 6. So that's how we broke the trinomial and factored it into two binomials, one x plus 8, the other x minus 14. So we're not finished solving for x, but we've now got the x's down to an exponent of 1. So we will set each factor equal to 0 and solve for x. So x plus 8 equals 0, x minus 14 equals 0. We subtract 8, so x could equal negative 8, or x could equal positive 14. So this is where we will have a discussion or think through what really makes most sense in this scenario. We're finding Ray's age. Well, we found two possible ages for Ray. He's either negative 8 or he's 14. Hopefully, you recognize that negative 8 really doesn't make sense for someone's age. So that solution is not possible in this word problem. The only one that's possible is that, X is Sam. Woo, got myself off. Anyways, for whoever's age, they can't be negative. So X, remember, stands for Sam. And so this is telling us that Sam must be 14. He can't be a negative age. If we know Sam is 14, then 14 minus 6 will give us Ray's age 8. There we go. All right, so Ray would be 8 years old in this scenario. All right, let's look at another one. Here we're given two consecutive negative integers, they are consecutive, that means one after the other, have a product of 20, what are the numbers? So we are dealing with two numbers, so we should have two missing variables or two expressions for things we're looking for. So I'm going to call that my first number and my second number. Let's just call our first number x. If the next number is a consecutive negative integer, then we can state that as an x minus 1 to get the next number in the sequence. You could also state here, though, that x plus 1, because let's say you had negative 5 as one of them. You could get the next consecutive one as negative 4, or go in the other direction as negative 6. And either way would work to get the next consecutive one. And I'll show you that work as we go through here. But here it tells us that they have a product, so either of these expressions for your second would work. You can choose either one that makes sense to you. Usually when people see negative, they think, oh, I need to go left on the number line, so they're subtracting 1. That's why you might see the minus 1 there. But they have a product of 20. So my first number times my second number should have a product of 20. Over here on the right, you'll see how it will still work if you used x plus 1. So we set up x times x minus 1 should equal 20, and we will start to simplify by distributing and setting equal to 0 to solve. So that gives us x squared minus x equals 20. Then we need to subtract the 20 to set our equation equal to 0. Since we do have an exponent higher than 1, the process is to set equal to 0. Then we factor the left side. So that will give us an x minus 5 and an x plus 4. The factors of negative 20, that add up to a negative 1. The middle term's coefficient would be negative 5 and positive 4. So that's why we get x minus 5 times x plus 4. Take each individual factor, set each individual factor equal to 0, and get x to be either 5 or negative 4. This is where we do need to stop and think about what makes most sense in this word problem. We're looking for consecutive negative integers. Well, 5 is not a negative integer. And if you were over here using x plus 1, you would have gotten the 5 as the negative, but the 4 positive. 4 would not be a possible solution. So regardless of which way you set up your expression, we're still getting one positive, one negative. Only the negatives will work. So if I'm over here and I used these expressions, if my x is negative 4, then to get the next value in the sequence, we would do -4 minus 1, which is -5. If I had done the x plus 1 scenario, I would have my x as -5, and then done -5 plus 1, which is -4. So either way, we get the combination of -4 and -5 as the two consecutive negative integers. All right. Here we have our next problem. The Monroes want to plant a rectangular garden. The width must be 4 less than the length, and the area is 96 feet squared. Find the length and width. So we've got a rectangular garden, and we're being asked to find the length and the width. So that's our cue that we need to be defining variables or expressions for length and width. So let's find the sentence that helps us identify those expressions. So here we have in the second sentence, the width must be is kind of like your is. So that's where your equal sign would go for width. 4 less than means subtract and switch the order. Less than the length. All right, so we know the least about length, and we know a lot about width. So that means length should be our variable. You can use L, X, whatever you want to use. I'm using X. Now we're going to write our expression for width using length's variable. So the width is equal to whatever the length was minus 4. Okay, now we're told that the area of this garden is 96 feet squared. Well, if we're dealing with a rectangle and we've got a length and a width, then the formula for area is length times width. So what this really means to do is replace area with 96 and then your length and width with their appropriate expressions that we just came up with. So that's going to look like x times x minus 4, x was length, x minus 4 was width, is equal to your area of 96 feet squared. From here, we solve for x, so we'll distribute to get x squared minus 4x equals 96. And because of that higher exponent, to solve this, we're going to set equal to 0 and factor from there. So you need factors of negative 96 that add up to -4. Ooh, there we go. So -12 and +8 will make the that combination. And that gives you your two factors for this trinomial without a coefficient. Set each factor equal to 0 and solve for x. So we'll get that x can equal either a +12 or a -8, because we set each one equal to 0 and solve for x. Now, we're dealing with a length and a width. This is a scenario of distance. So the distances should be positive. It wouldn't make sense to have a negative distance. Because of that, x, or our length, must be equal to 12. And then if the length is 12, put x's value of 12 into the other expression. 12 minus 4 will give you the width of 8. And they are feet. I should have the units here. Okay, for our next example, we have a square banner that had 4 feet added to its width and 2 feet subtracted from its height. The banner then had an area of 91 feet squared. How long was a side of the original banner? All right, in this scenario, it's really important that you see we're dealing with a square banner and to understand the properties of squares. Squares are the same length all the way around. All the side lengths would be the same measure. So I can name the length of each side of my square as x, the original length. Then we do a couple things to it. We have a length and a width of a new banner that's created, where the banner had 4 feet added to its width and then 2 feet subtracted from its length or height. You can think of it like height or length. Either way. So whatever the width was, we are adding 4 to it. And whatever the height was, so here we're adding 4 to get to the new one. Whatever the height was, we're subtracting 2 to get to the new height. So I'm going to name those width and height expressions as the x plus 4 and x minus 2. Tells us once that happens, then the area of the banner is 91 feet squared. So again, area of a rectangle is length times width, and we'll replace the length, or I guess in this height, our width or height, however they're referring to it here, base times height as x plus 4 times x minus 2 equal to the area. So from here, we will solve for x, which means we need to multiply everything out on the left side to simplify first. So we'll get x squared minus 2x plus 4x minus 8, all equal to 91. Then we will, because of this higher exponent, we need to combine like terms in the middle and then set equal to 0. So here 4x minus 2x is 2x. And then we subtracted 91 from both sides, so a negative 8 minus 91 is how we get that minus 99 on the left. From here we factor, so now we've got a trinomial without a coefficient, so we need factors of negative 99 that add up to 2, which are 11, positive 11, negative 9, and those are how we'll fill in the binomials that we factor to. Now take each individual binomial, set each one equal to 0, and solve for your x's. So x equals 9 or negative 11. Once again, we're dealing with a length or width of something. So a width or distance or measurement cannot be negative. So the only one that makes sense is the positive solution. So the original side of that square, x value should be 9 feet. So I think you're starting to get the hang of these, hopefully. So what I'm going to do is allow you to now try some on your own where you read the example, work it out, pause the video when you're ready to check, hit play. So here's your next one. Okay, so hopefully you've done the problem, you're ready to check. The area of a square is equal to 5 times the perimeter, or the area of its perimeter. Find the length of a side of the square. So here our square's lengths will be the same all the way around. And so if I know that each side is x, then to get the area, we'll do length times width, x times x, which simplifies to x squared. And the perimeter, we're also dealing with its perimeter, is equal to the sum of all the sides. So if there's 4 sides of x, then the perimeter's expression should be 4x. From here, you set up your equation. We're told the area of the square, so we know the area of the square is x squared, is equal to 5 times the area of its perimeter. And its perimeter was 4x. So we get x squared equals 5 times 4x. From here, simplify. Because of the x squared, we need to set equal to 0 and factor. And for the factoring method here, we need to pull out a GCF. Remember, that's the first method of factoring to always look for. And so our two factors are x and x minus 20. So we'll set each of those equal to 0. So one solution is x equals 0, and the other is x equals positive 20. Well, if we're thinking about find the length of the side of a square, if this square exists, it's got to have a length larger than 0. So the 0 solution doesn't make sense. Only the one that's 20 makes sense. Okay, here's your next one. I'll let you work it out and then come back to check. All right, so hopefully you're ready to check. A rectangular plot is 6 meters longer than its width. The area of the plot is 16 square meters. Find the dimensions of the plot. So if we're looking for dimensions, that's a length and a width. So we need expressions for both of those. So hopefully you set up your width as x because that's what we knew the least about, and the length as x plus 6. The area is the product of the length and width. So the area should have been equal to 16 as it was given. Simplify. and set equal to 0. Factor, set each factor equal to 0 and solve. You can't have a negative length for your plot, so the only one that makes sense is 2. So if x is 2, that means the length is 2 plus 6. So 2 plus 6 equals 8. So that's how we get the 2 dimensions, 8 and 2. All right, here's your next one to try on your own. Click pause when you're ready to check, click play. All right, so hopefully you have worked this out. We have 2 consecutive numbers. They are consecutive, so they're 1 away. First number should be x or whatever variable, and the next one is plus 1 from that because it's the very next number. And their product is 72, meaning multiply those 2 together to get 72. We then need to simplify and set equal to 0. From there we factor and find that x equals 8 or negative 9. Now this problem did not specify positive or negative, so actually both solutions could be valid. And so since they're both possible, we're actually going to have 2 potential solutions. So the first would be, what if x is 8? Well, if x is 8, then 8 plus 1 is 9. So one combination of answers is 8 and 9. Make this true. However, if x is negative 9, instead, then negative 9 plus 1 equals negative 8. So another combination is negative 8 and negative 9. Both of these work, so you do need to state both because they'll both fit this scenario. So we're not always crossing out an answer. If both could work, we leave them. All right, and here's your last one to try. This one's probably slightly more challenging just because of the nature of what this is referring to. We've got chairs, 54 chairs in a room. So think about these chairs being lined up in rows and columns, okay? So with that said, go ahead and try it out, and then we'll come back together to check. All right, so the room contains 54 chairs, and the number of rows is 3 less than the number of chairs per row. So I've defined my variable as just the number of chairs per row. If you think about it, we've got a certain number of chairs per row and several rows. So we're really starting to build a rectangle here. And if you wanted to quickly count the number of chairs in the room, you could count the length and the width, or the number in the row by the number in the column, multiply them together, and that gives you your total. So that's where we're going with this. The number of rows is 3 less than the number of chairs. So if you've got x chairs per row, 3 less than that gives you the number of rows. All right, from there, multiply them to get 54. Simplify, set equal to 0, factor. X should equal 9 or negative 6. You can't have a negative amount of chairs in this room. So that solution doesn't make sense, meaning that there are 9 chairs per row. And if we put 9 in here, 9 minus 3 tells you the number of rows being 6 rows. And that concludes our word problems lesson.